Hi, my name is Ziren Lin, and this is my presentation for the project Face Recognition by using Hard Cascade Classifier and Convolutional Neural Network. So, the face recognition is now becoming more and more popular as a computer vision and image processing research topic since it has many application scenarios like video surveillance, personal information verification, etc. In the early 1990s, face recognition was proposed since the invention of a classic algorithm, the eigenface, and the subsequent methods including local feature extraction and learning-based local descriptors were also popular after that. However, such methods have limited performance since they try to recognize human faces by using one or two layers and only focus on addressing one of the complex face components such as illumination, posture, expression, and disguise. In this case, some integrated algorithms are needed. Um, in 2012, along with the winning of AlexNet in ImageNet competition, deep learning come to the stage and drawn a lot of attentions. Convolutional neural network, known as one of the most famous deep learning models, uh, contains multiple layers which can do feature extraction and transformation. So, unlike the holistic feature processing, CNN has a better performance on adapting light, pose, or dynamic invariance. So, for the in this project, a CNN model was constructed, trained to implement face recognition. When we need to catch and recognize the face through a camera, we can use a pre-trained classifier to find the human face, then apply the CNN model to determine who it is. Um, uh, in this project, I use the dataset from labeled faces in the wild home. I choose 10 of them to uh, to be the training data, and I add my photos to the training data as well. So for the convolutional neural network, uh, it has great capability of extract features as we mentioned before. Unlike the holistic features uh, extraction methods, it can adopt light, pose, and similarity among different people, then keep nearly all the human face features. So to achieve that, it mainly contains convolutional layers, pooling layers, and fully connected layers. So for the convolutional layers, they are probably the most important part in CNN. The convolutional layers are like the sliding windows. They extract the features by applying a mathematic operation, convolutional, of a certain image and form a feature map for the image which can represent the location and significance of these features. In this case, the CNN model can keep many features at one time. Then the pooling layers. The pooling layer is to make compensation to the drawback of the convolutional layers. For the convolutional layers, the biggest problem is it keeps all the features at exact corresponding positions. So once we rotate, crop, or reverse the original image, we will get a totally different feature map. To solve this problem, we can implement downsampling by using the pooling layers. The two main pooling methods are max pooling and average pooling. So the next is the fully connected layer. Fully connected layers can address the high-level features of the original images. It is usually added to the output layers and is also a cheaper way to find the nonlinear combinations of the high-level features. So next, for the VGG16 model, it is a variant of the CNN model with some modifications to the huge size kernel filters. Instead of putting large size kernels to the network, it replaces them with some consecutive 3 multiply 3 kernels. With the application of these smaller kernels, VGG16 can seek higher performance by adding more layers and reducing the parameters of the network. Therefore, the VGG16 network is comparably simpler and can perform better. Here is the structure of VGG16. So in this project, the main part is to recognize the human face via a camera. But how do we find a face in a certain frame? For the face detection job, I apply the Haar cascade classifier. So the Haar cascade classifier is a classic object detection method which we can apply it to detect human faces. So the basic conceptions of Haar cascade classifier is the first we calculate the Haar-like features of the image. Second, we use the integral image to boost the calculation of Haar-like features. Then we use the AdaBoost to train and classify the human faces. So finally, we cascade classifiers from different stages. So here is a sample of the face detection by using the Haar cascade classifier. So next, for the model I constructed in the project, here is parameters of the layers. So here I have 4 convolutional layers, 2 pooling layers, and 2 full connected layers. It is much simpler than the VGG16, so that I can run the code on my local device faster. So this is the training data of my model. So here are some testing samples of my model. I can detect my face through a camera, and also my model can recognize my face and recognize my friend's face as a unknown. since this face is not in my database. So the result shows that my CNN model can effectively recognize the person in the database. When I use the camera as the network input, it can also recognize me and detect other face as a stranger. So overall, my model has achieved the goal of human face recognition. However, the accuracy is around 80%, which is not as high as I expect. This is because the model is not that complex due to the hardware limit. So if I can train my model on a larger server, I will probably make my model more complex. So I can do a little demo on my model. Here I just run the read camera code. So it can detect my my face. And thanks for watching.